Hello everyone. So today we are going to do Leetcode daily challenge question swap nodes in pairs. So in this question, what are the requirements? Is something like this that oh okay. So here we would be given with a linked list. Just don't see the code, just see about this only. Now here the thing is that we are given with a linked list, right? And what we are required to do is we are required to swap the nodes in pairs. Basically, these two would be swapped together and these two would be swapped together. And then our final linked list would be something like this, right? Means one is swapped with two, so it simply becomes 1, 2 means 2 to 1, and then 3 swap to 4 and it simply becomes 4 to 3, and the linking between them would be something like this only. So this is what we are required to do. Now in this question, the major thing is that we are required to devise a solution in which we would be simply first thing, that is we would be swapping, right? Basically we are swapping these only, right? First thing would be this. And second thing would be that even when we are swapping these nodes, right? So we are required to link all these nodes in such a manner that we are required to simply link all these nodes in just perfect manner, like means saying we are swapping them, right? So after swapping them, then also the links should be maintained in proper manner only, right? That means when we swap 1 and 2, then it becomes 2 and 1. So 1 should simply point towards 4 and 3 rather than 3 and 4. So this is what I am saying, that we are required to simply link them properly. So this is the thing. And the third point which is there could be some confusion with the head node also. So regarding that, means avoiding that particular fact, we could simply use a dummy node, and that dummy node could simply help us for the confusion which could be created with the head node. So yeah, third thing would be that we would be doing a solution using a dummy node. So now, before starting the code, okay, so let me explain you with the code itself only. Means, whatever code I've written, I'll simply first try run it only. Means basically what my each line of code means, that I'll show you here. So now here the thing is that what I've written is my code simply have 3 portions, and these 3 portions are: first is for the fact for handling the dummy node case, in basically for the head portion. This is for my first part, and the second part is my main part just for iterating over the whole linked list, and the third part is for swapping the linked list. So these are the 3 portions in which I have coded my solution. Now comes the first part. What I've done is I've simply taken a list node start. This is for simply getting rid of confusion of the head node. So I've created a dummy node which I've named as start, because this would be the starting for now. So I've created my new list node and given it value with 0. And then what I've done is I've simply linked that starts next, means basically my dummy node, with the head of the linked list, which is being given to us as input. Alright, so now our whole linked list is linked with our dummy node in this particular piece of code, basically in this piece of code. Now comes the next part, that is this particular portion. In this particular portion, what we are doing is that we are simply traversing our whole linked list. How we are traversing it? That we are keeping a check that if our currents next is not equals to null, and even our currents next to next is also not equals to null. So in that particular case, what we are doing is we are doing 2 steps. First step is simply that our present current node, its next, that what would be its next, right? That we need to link it. Basically here the linking portion comes up. So how I'm linking it, that our current would simply start from 0, basically from a dummy node only, right? And we are taking that particular node here, which we are required to join, but not we are required to swap it. Like this, I have coded this particular solution that my current next, so that whatsoever I am required to attach, that would be here, and its next would be simply attached with those two nodes, which would be now next swapped. Right. So that's why I've taken a swap function where I've simply passed parameters at current next and current next to next. That is 1 and 2 would be passed in this particular function at this particular time, right? And then what I've done it the next portion is that now after we get our swap nodes and they are completely linked with our dummy node, then what would be our next node to be taken into consideration so that we could work for next swapping. So because of that fact only, now our next node which is required to be attached would be our this particular node, means current equals to current next to next node, right? So basically not the not the just next node of our current, but the node which is after swapping we get, which is just next to next. That is here our current node is this one, right? So after swapping, what we'll get? 2 and 1 would be swapped, right? So our final will be 2, which is pointing towards 1. So now our new current would be 1. And why we have taken this 1? So that after this, we would be having some other nodes, right? So we are required to perform swapping for those nodes. So to perform swapping for those two nodes, we are required to have a node which could be attached, right? The way we were having this node 0, which was required to be attached so that we could have this 2 and 1, right? So that's why we are taking 1 here. Basically, current next to next is being taken here so that we could simply swap our further nodes. So these are the two steps which are being required to write in this particular while loop while performing the solution. And when this particular while loop would be ended up, then at that particular moment what we are required to return is the starts next portion. Basically this will return our head portion because our start was simply starting from the 0 dummy node, right? So we are simply required to return that particular node which is just after our start. That is our head node. At that moment it would be 2. So it will return 2 and then whole linked list. So this is the thing. Now here comes that swap function which is being used here, right? So what we are doing in this swap function is we have taken next one and next two, right? And then here what we are doing, that our next one's next. Basically we are required to swap it. So while swapping, what we are doing in a linked list is we are simply changing the links. So how we are changing links here is that whatsoever is our first node and whatsoever our second node. So in this, our first node's next would be simply changed with the link of second node's next. That is, here our next one is simply this one, right? And our next two is simply this one, right? So our next one would be simply changed. Next one's next would be simply changed equals to next two's next. And our next two's next is simply 3, right? So our linking would be changed towards this. So this particular is done. But as we are swapping, so what we are required? We are given with this and we are required to do this, right? And whatever nodes are there. So in that context, our one has been changed to this particular portion. That is, next one is simply, next one's next is simply changed to next two's next, right? But now we are required to change our next two's next equals to next one. So that it could simply reverse its pointer, right? So that's why we are writing this particular portion of code here, that next to next equals to next one. So that it could be traverse, simply change its pointer like this. And at the end, we are required to return next to. Basically, our next to would be the starting of a linked list at this particular portion, right? So that's why we are returning next to here. So that here in this swap function, our current next, that is 0. So next 2 is being returned, so 2 would be there and 1 would be there, right? And then our whole other linked list, that would be there. And then our current would be simply equals to, our current was this, Now our current would be this. Basically, the new portion that would be here. So this is what we are required to do in this particular portion of code. Now comes the part of time complexity and space complexity. So here we are not using any extra space, right? Even the dummy node is simply a single node only. So here it is sort of just a variable. So here we are not using any extra space. So the space complexity is simply order of 1 only, but the time complexity, that time complexity here is order of n. Basically, here is for the length of our linked list, right? So here the time complexity is simply order of n, as we are not, we are just traversing a whole linked list, and thus it is order of n only. So this was all for this particular question, and this is the iterative method. I had explained the recursive method here. It's simply the iterative one, and it was much more convenient. Although I guess recursive one would be much shorter in size, but yeah, I'll try to make that video also. Basically, just start with this iterative one here. So this was all for it, and if you have any doubt or any query or anything, you could comment that out, or any other suggestion for this particular question, you could comment that down. So thank you.